Greetings. My name is David Havlin. I'd like to talk to you about considerations in purchasing a telescope. We get asked this question very commonly at star parties, so I'd like to take quite a number of minutes and address it here. I'm based here in the Houston area where we've got the Fort Bend Astronomy Club, Johnson Space Center, Houston Astronomical Society, North Houston Astronomy Club, as well as the George Observatory and Insperity Observatory, and I encourage you, once this pandemic is over, to go visit those two observatories because they're quite a treat and quite a place to visit and see the night sky. The question we get a lot is, what sort of telescope should we buy? And that's kind of like asking somebody to buy a car for you. You may have your heart set on an F-250 and they're going to come back and suggest a smart car. Well, that's probably not quite what you're looking for. So as I said, this is an informed, and it needs to be an informed and personal choice. Our first recommendation is, if you don't know, don't buy one. Please avoid impulse buying. You can do impulse buying at the grocery store, but not when looking at a telescope. Just don't open the wallet. Do you need a telescope to see what is up there? No, you do not. First thing you need, though, is some relatively clear skies, and the second thing you're going to need is kind of a map of the skies. I like this Terrence Dickinson Night Watch. It's very handy. It's got some charts in it that I'll show you later on. Good star wheel. You can find these at Half Price Book or Barnes & Noble. And also you can get star charts from Sky Maps on a monthly basis. And I'll show you these. In a little bit. A pair of binoculars, if needed. We'll talk about telescopes after we talk about binoculars. Here's what the star chart looks like for June of 2020. It's an evening sky map. These are PDFs that you can print, and they're free. Gives you the idea of what's going on with the northern hemisphere. You can also get them for the southern hemisphere. You've got a sky calendar over here to the left. Symbols of what things are on the map over here, down here on the right. When you flip the map over, it tells you about the celestial objects, gives you an astronomical glossary, what can be seen with the naked eye, what can be seen with binoculars, and what can be seen in a telescope. This is actually a very handy thing to have. Now, if you move up a little bit, you can get the Pocket Sky Atlas, also from bookstores and from Amazon. It's got quite a bit of information in there. It's really, really good. Make sure you get one that is dew resistant, so if it gets wet, it's not the end of the world. You can just wipe it off and go from there. It's got quite a bit of information. For example, here the upper half of the Orion constellation and what you would see in a Telrad. And we'll talk about Telrads as we go. But it gives you the relative size of stars, where galaxies and where nebulas would be. This is an extremely handy guide, and it's like about $19 on Amazon. A nice chart legend, and we go from there. Outside of clear skies and a map of the skies, good pair of binoculars would be good. Let's talk about binoculars. Binoculars are a good place to start. They'll give you the forest view, if you will. They'll give you the perspective of what's going on. Decent binoculars starting at 7x50 are a good place to start. 7 is the magnification. 50 is the diameter of the front objectives in millimeters. So up to 7, 8, 9 can be handheld. Anything much above 10 are best mounted on tripod, as they can be modestly heavy. I have a pair of 15x90s, and they weigh about 2.5 pounds. I usually mount them on a tripod. I've got a couple of 7x50s that I'll use by hand all the time. If you're serious about binoculars, mounts can be made if you're so inclined and have the skill set in the wood shop. You can also buy mounts for binoculars. I do recommend you double check the specs and make sure you don't overbuy the binoculars for the mount. Make sure the mount can handle what you've purchased. For the backyard, is a good place to start. You may have to travel in search of darker skies. I do recommend a chaise lounge because the armrests are often a good place to put your elbow. We do recommend bug spray, particularly in the Houston area. So that's where the reference of off comes from. All right, let's talk about telescopes. This gets complex and is a personal choice, as I mentioned. Please avoid what we call holiday scopes. Excuse me, these are scopes that are sold only on the basis of their power. Please avoid them at all costs. Basic recommendation, please avoid the big box stores and discount stores at all costs. This scope is sold solely on its magnification. When you see that, walk away. You see something Galaxy 675? No, you're not going to get 675 power out of this scope. This scope will be a severe disappointment. Many of the images on these boxes are artist renditions, hand-painted, or they are pictures from the Hubble telescope. Anything that's based on power, walk away. These holiday scopes are bought usually from discount stores September onward through Christmas. I've short-circuited a few people from buying them at box stores myself. You'll see them going on for around 100 to 125. They usually have very poor optics. For about 100 to 150 more, you can get a good quality scope that can last a lifetime and render many hours of viewing. The problem with these holiday scopes is their product is based on magnification, not resolution. And resolution is the most important characteristic and factor in considering a telescope. Big difference between magnification and resolution. Here's the Houston Astronomical Society, and what I've done is I've taken one of the letters here and really blown it up. Can you tell which letter it is? Resolution is key. And the problem is once we have magnification power exceeding resolving power, it's going to start getting blurry, and increased magnification is just going to make the blurry blurrier. So this is what we call empty magnification. And before I leave the slide, I'll give you a little hint. This is the I, but it could have been the L, could have been the M, or N. But you can't tell. And this leans exactly to the point. Resolution is key, but magnification is only part of the picture. So the rule of thumb is you'll get 40 to 50x, 50 power per inch of aperture, and that assumes the lens or the mirror is decently crafted and is of a decent quality. So a 2-inch scope might get you about 90x. There's no way you're going to get that 675 out of that 2-inch scope. Mathematically you can. Practically you cannot. A good 11-inch scope will get up to about 490. 36-inch, that's what we have at the George Observatory, can get to about 1440. But aperture is key, but as the aperture goes up, so will your cost, and that's another factor you have to consider. Let's talk about the 3 different types of telescopes. This particular one is called a refractor. It's much like what the pirates used back in the day, what surveyors use today. Focal length is the length of the tube. It can be used both night and day for terrestrial work. Requires very little maintenance. Superior optics, the light comes in, comes straight out, and here's a simple example of a refractor on a alt-azimuth mount. Superior optics and clarity if it's of good quality. The catch is the money's going to skyrocket once you get past about a 4-inch aperture, because this is glass up here, and you're talking about a refined piece of glass that's more than 4 inches. Your price is going to go up. So will your transportation issue. Aperture, though, is key. I do recommend, no disclaimer, this is the website for the Orion telescope. It's a great place to go and learn more about scopes. Here are examples of refractors. These are high-end refractors from Takahashi. You are probably looking at about $12,000 right here. So you want to be very careful. These are very, very good scopes. There's one here and one here. Let's talk about a reflector, the second type of telescope. Here, the primary mirror is down here. The secondary is up here. The light comes down, hits the primary, goes to the secondary, comes out the eyepiece, much like what this one is here. Outstanding optics, often drop and go to a point. Focal length is the length of the tube. They're very economical. Get a big bang for the buck. It's usually a highly recommended starter scope. The disadvantages, they may not be so portable once you get above about 10 inches of aperture. Get about a 10-inch mirror. You add clock drive, encoders, GoTo, and you'll add to the cost and a little bit of the weight and the setup time too. You can also build your own. These two gentlemen have built these. These wheelbarrow handles are for the transportation side of it. Wait a minute, where was the tube in that? Well, the tube is taken out by these trusses. And this makes it fairly compact and portable. These are pretty decent size scopes. I do not recall the specific dimensions on the mirror, but I think this is 18 and 14. I'm not 100% sure. You can go even larger. Dobs like this, you just wheel it around and point. This is in a very large one. I believe this is the largest amateur Dob that's out there. I think it's something like 77 inches. These ladders are not for decoration because the eyepiece is up here. And in this case, as this gentleman showing you, the eyepiece is over here. So you've got to get up that ladder, be very confident on the ladder to do the observing. So as I said, yeah, it's just not for decoration. They do make what are called Newtonian reflectors, like such as this one, on an equatorial mount. Here's your standard Dob. We'll be talking about that as we go further into this talk. Third basic kind of scope I want to talk about is a Schmidt-Cassegrain. It's compact. Light passes through the short tube 3 times. The focal length is 3 times the length of the tube. Disadvantage? Its cost. They tend to be a little on the higher price side. They tend to be heavier, often with heavy mounts. The light comes in, hits the primary, hits the secondary, and comes back here for the tube. Comes out the back side of the scope. Here's an example of one on an German equatorial mount. This is rock steady for imaging. Cost, portability, and setup time takes me about 20-25 minutes to fully assemble this thing and about another 15 to align it. So I'm looking at 35 to 40 minutes before I'm doing much with it. I will usually check the weather and make sure I've got 2 or 3 good clear days before I set this one up. Whoops, wanted to go this way. What is power then? We never really addressed that. Magnification power is computed by dividing the focal length of the scope by the focal length of the eyepiece being used. So if I take a 13, one of the Dobs that I showed you, this 1300 millimeters, and I'm putting in a 25 millimeter eyepiece, then with that eyepiece, I'm looking at things in the sky at about 52x. If I take that 3000 millimeter Schmidt-Cassegrain in the previous slide with different eyepieces, I'll have 32 millimeters for 94, 25 for 120, 7.5 for 400. Make sure that we stay visible. Again, aperture is key, and it's a function, power is really a function of what eyepieces you put in front of it. Choice depends what you want to do. Do you want to observe, take an image? What sort of mount do you want? Portable. What are you going to transport it in? You can't take one of those massive Dobs in a smart car. That's just not going to work. But the rule of thumb is get the largest aperture your budget and significant other will allow. What kind of scope are you thinking of? What do you want to do? Do you want to do basic observing? Do you want to ultimately consider imaging? These are all things you have to consider. I suggest you go to star parties. I'll come up with a list of, at least in the Houston area, the astronomy clubs. Try to find. I'll talk about how to locate a club in your area toward the end. But I want you to not only look at the stars, but I want you to look at the scopes as well and see what you like and what you don't like. As I said, we want you to make an informed choice. Extras. Mount and accessories will add significantly to this cost. Equatorial mounts, rock steady for imaging, such as this one, will bring the price up. GoTo capabilities will add to the cost of it. It's not uncommon for astronomers to have more than one scope. I've got this one, and I've also got this one. If I want to set up for 2 or 3 days an image, I'll use this one. If I just want to drop and go, I'll pull this one out of the closet and I'm up and viewing in 5 minutes. It depends what you want to do. Sight unseen, I usually recommend a 6 to 8 inch Dob. Not uncommon, as I said, not uncommon for astronomers to own multiple scopes. Scope like this is easily portable. These are springs that hold the tube onto the mount. Pop the springs. You can put this into the car separately. You can put this into the car separately. It doesn't have to be transported as an entire unit. Go-tos or not to go-tos. For starters, we strongly consider suggesting folks learn what's called star hopping in the sky, to learn your way around the sky. You need to be able to know if the go-to is correct or not. But as you add go-tos or encoders, your cost will come up too. I'll bring this up again a little bit more later on. You want to build your own? Sure. What's this one made of? These are weights you can find at sporting goods stores, plates and everything you can find, little motors I'm sure you can find. Well, this gent is one of those guys who can look at something and say, I can make something out of that, and that's exactly what he did. The two components of this are actually an above ground pull filter. The upper band up here is this here, and the base of this is the base over here. There you go. Excuse me. Basic Dob is a metal tube, in this case made by Orion, but you'll often find a number of Dobs are made with sonotubes, straight from Home Depot and Lowe's. All you really need is the mirror, way to mount that secondary mirror and a spine, and a place to mount a focuser, and a sonotube will work quite well. Go-to cost too much? Looking for alternatives? You can modify scopes yourselves very easily. If you have the skill set, people have often made their own bases. This is clearly, I just dropped the name of this plywood. But you can cut it and mold it. I'm sorry, you can cut it any way you want and style it anyway. Set up your equipment on it and go from there. It works out real well. Here's a Dob that's made with a sonotube. I think he's wrapped it a little bit. The base again is a kind of a box that wraps around the tube, and he's got it sitting here on this semicircle. These white things here are nylon riders, so we can move the scope up and down. The plate is not shown well here, but we'll go down to this one. This bottom plate is actually a triangle, is what's shown up here, and then the circular plate rotates, and the whole scope can rotate 360 degrees, and what you see here is something equivalent to a Lazy Susan. And the scope is the top plate with the scope is attached to this. These provide a little bit of friction so that it stops when he needs it, but you can also get this, if you don't have the Lazy Susan, you can also do this with a large sheet of Teflon. I've even seen people use old records for it. So there's quite a bit you can do. But you can also make modifications to find objects. This is an application called Sky Safari. I'll talk about it shortly. It gives you, for a given object, an azimuth and an altitude. What can you do with that information? Well, this is your azimuth right here. 000 is due north. Here's 350. Here's 355. Here's 005. 010. North is there. If this is lined up due north, and you've got the coordinates 276 and 31, you spin this around till you get to 276. This is on the tube itself. You raise this until you're at 31 degrees, and if your timing is right, the object that you're looking for should be in the viewfinder. Now the scope's got to be level. These are modifications people make to their scopes all the time. Scope's got to be pointed very close to north celestial pole or due north as possible. Any error will be proportional. You want to try to keep that error below a couple of percent. Let's talk about assisted setups. GoTo computerized systems drive the scope to a desired object, but you've got to do quite a bit of setup. You've got to align it to the north pole, north celestial pole. And this lid here pops off, and there's a small scope through here, and the goal is to actually try to view Polaris through the long axis of the scope. Have the scope up here, tell the computer where a couple of alignment stars based on longitude, latitude. It now knows where things are in the sky, and you can go to them. There's also what's called PushTo, computerized system, though, where you are the motor and you manually move the scope to where the computer says to. You align the scope on a couple stars that you likely need to know and have a star chart handy. Select a desired target and zero it out. In this case, this person's selecting the Orion Nebula, and it's saying go in that direction to 174 and go here down to 36. When both of these read 0, hopefully the Orion Nebula will be in the viewfinder. This PushTo is often called encoders. You may see that, maybe a slightly older term. So what can you see in a scope? Well, this is actually the Orion Nebula. I'm sorry, the Orion constellation. Part of it's not all completely there. There's parts out here and parts up here. This is Betelgeuse. Here's Rigel. Here are the three main stars of the belt. And down here, around where Orion's knee is M42 and M43, the Orion Nebula. This is a highlight in winter. It's a beautiful thing to see in a scope. If you've got an 8-inch scope or a 6-inch scope, it will be incredible to see. This is a photograph from this gentleman's backyard in Ontario, Canada. There's his website. 43, 42. This is a planetary nebula. This place like this is where stars and planets are born. It's one of winter's outstanding objects. You'll also see things, galaxies, usually in blues and grays. Same thing for the Dumbbell Nebula, also in blues and grays. And I'll tell you where to find these in some upcoming charts, because we've got to talk a little bit about star hopping. Smart tools to use. What I handed up to this point were books and sheets of papers you can get out of your printer, but this is something for the smartphone. SkyMap is, I believe, as a Droid. I think there's something very similar for iOS. It's very easy to use, IDs planets, stars, and helps you learn the major stars in the sky. This is an important thing. So you want to know where Vega is, where Iterum is, and other stars of that nature. Very easy to use. However, if you look at an object and you click on the object, it's not going to tell you a lot about it. That's your price for being free. It's good for learning the skies and learning your major stars. If you want something that's going to give you a little bit more information, there is Sky Safari, and it costs, but it's very good. It's fee-based, it's intricate, it's got a deep software. If you learn it, you can configure it. You can configure it to drive a telescope with it. I often use it at the George Observatory. Somebody will ask me, "Oh, how far away is such and such?" I don't have that stuff memorized. I'll pull out Sky Safari and say, "Oh, it's 2,700 light years away, and it's so many light years across." It's a very handy app. Second big step is learning what major stars and what points to what. We strongly encourage everyone to learn to star hop. It will take time, and it's crucial to your operating computerized systems. You need to know, just like with your car's GPS, when the car tells you to turn right and you know better and you know that you need to turn left, you need to know that your PushTo or GoTo are going in the right direction. So it does help to know where your major stars are. So the catch is, and I'll repeat this in the next few slides, find a constellation you know, usually the Big Dipper or Orion. Start with that one, and then find out where it points. In this case, this points to Polaris, and Polaris kind of leans over here to Cassiopeia. These two over here lean up to a star called Capella, Castor and Pollux in Gemini, Regulus. The tail of the Big Dipper leans down toward Arcturus. These two over here lean toward Deneb and Vega. We'll talk about these in a little bit. Big Dipper's pointing over here to Polaris. You can kind of start seeing once you get one constellation. Alright, there's no easy way to around this. It will take time, but it will be worth it in the end. Again, Ursa Major here pointing to Capella, Castor Pollux. These point over here to Orion. And you just go from one constellation to another, and then once you're familiar with that, when you kind of leapfrog to another, it's the best way I can describe how to do it. Now you remember those two stars, Vega and Arcturus? Well, between them we've got Coryona Borealis and Hercules, and over here we've got Cygnus. But here they are again in a different program called Stellarium. Those previous slides were from Terence's book. This program is Stellarium. It's free, and it runs on Windows, Mac, and Linux, and it's very, very good. It's fairly easy to get going. Tells you what's up in the night sky right now, and it too is sophisticated enough that you could drive a scope with it. So let's come back to Cygnus and Lyra, these two, Vega and Deneb over here. What can you see? If you can find Vega, and you can find this constellation sitting right here, and if you're in dark enough skies, you can actually make out these two stars come down to that midpoint, and you're actually going to see this guy, the Ring Nebula. Same thing for Cygnus. Deneb over here. This actually makes the Northern Cross in the North American sky. Just kind of basic geometry is how I think of it. Same stretch down here. Same stretch over here. Come right here to M27. It makes almost a rectangle, if you will. And you can see an object that looks something like this. Now this is in reasonably dark skies. Now both of these are in color because these are photographs. By your eye, these will come up in grays and blues, and they're still very spectacular, even by eye. Hercules, that one that was in the middle, between Coryona Borealis and the other one, there's a keystone made up of 4 stars. If you find this upper one here, it's only magnitude 3.5. It's not going to be too dim. It should be fairly easy to find in most skies. Come down part way, and you'll see this globular cluster. It's one of the finest clusters in the northern sky, and it is packed. Each of those is stars. There are galaxies tucked in there too. It's just an incredible object to see. The Big Dipper, Ursa Major. Remember, this guy points off to Polaris. You come around here to the bend. If you come back to here, Alkaid, between Alcor and Alkaid, and come about half the distance, swing down 90 degrees, M51, there's a gorgeous galaxy right here. Again, if you come back to Alcor and Alkaid and kind of do a semi-isosceles triangle, just lean it to the left a little bit, you can come up with another galaxy over here. The sky is full of these things. It's just incredible what's in there. You'll have open clusters, globular clusters, galaxies, planetary nebulas, all kinds of multiple different types of nebulas. It's really amazing, everything that you can see. And also, let's go right here. Here's the Big Dipper again. It's upside down. Here's the handle. These two back here, Mizar and Alcor, it's a double star, 2-star system. Those double stars are often kind of fancy and fun to watch too. So again, set yourself up with a map to start learning the skies. Pick up this book if you'd like. Parabinoculars is a good way to start, and we'll go from there. Then you can move on to the smartphone objects such as sky maps. Okay, little digression. The moon. It's up there in the sky. The brutal truth is most of the general public that shows up at outreach events have often never seen the moon through a scope. They look up at it and just see it with a naked eye. But in a scope, it is spectacular and is a very popular item at outreach events. What makes the moon a special object is it doesn't matter if you live in the rural area or in the middle of the bright city. The moon can always be readily observed. It can be a problem if you want to observe deep space objects, but it's there, out there, and it's not going anywhere, and you may as well look for it. My favorite phone app is called Lunafact. It draws the current phase of the moon depending on the date and time. Swipe left to increase or decrease the day. It pretty much does everything for you. Lunar calendar gives you the whole view of the month. It tells you when the moon's going to rise, when it's going to be straight up, when it sets. Not straight up, but its highest point in the sky. Also tells you when sunrise is, sunset, when twilight ends. It's a very, very handy app. There's a picture of the moon, just to get some landmarks. Mare Tranquility. We landed right about here 51 years ago. Got Mare Serenitatis, I'm sorry. Mare Ibrium. We've got various craters over here. I'll show some of these in higher detail. Here's something to think about. You've got this big one right here, Copernicus. You can see the beautiful rays that are coming off of it. And you can see it's rimmed completely, all the way around. Nice circle. Got it? Here's another nice circle right here. Yeah, this was an impact. Mare Ibrium was an impact crater. I forget how big the impactor is. I think it's something like 250 kilometers. It was a massive hunk of rock that made this crater. Now this hit when the moon was largely in its, I won't say liquid form, but semi-solid. This is all a sea of lava, as are these. These were at one time seas of lava. These mountain ranges occurred after the moon started to solidify with additional and further impacts. The moon is a reflection of what the Earth used to be. So let's dive into the moon just a little bit. Here's that crater I was talking about. It's Copernicus. Diameter of 93 kilometers across, probably 40 some odd miles. Depth about 3 kilometers down. About 800 million years old. This was taken by Robert Reeves of San Antonio, one of the better lunar photographers out there. These three craters, Ptolemais, Alphonsus, Arzachel, three completely different craters taken at three completely different time points. This is probably the oldest, intermediate, and youngest crater. This is the Straight Wall. This is that Arzachel down here. Just down here you can kind of see this straight wall. It's some 60 miles long. Less than a quarter of a mile wide, but it's just an impressive feature. And what you're looking at is the shadow, because you can tell from this crater, the light's coming in from right to left. It's coming in from the east side. Mare Crisium on the other side, again photo by Robert Reeves. You can almost envision two eyes, kind of a crab. It's a beautiful crater when the moon is in its early phase. One that I've taken of Mare Humorum on the east side. The moon is a wonderful topological playground, and we were there 6 times, 69 all the way through 1972. We will get the question, can you see the flag? No, you cannot see the flag. Plain and simple. The closest the best resolution we've been able to get with Earth-based telescopes is anywhere from about 3/4 of a mile to a mile. So there's no way you're going to see a flag that's about 4 feet across. We can't even see the lunar modules at the landing sites because they're only about 30 feet across. We do see the shadows of them with the Lunar Reconnaissance Orbiter. So, with that, let's get back to the reason you're here. Take-home message for telescopes is we want you to make an informed decision about buying scopes. We want you to choose wisely. We do not want you to make a choice you will regret. So please stay away from the big box stores and scopes sold on purely magnification. In the Houston area, find one of the 4 clubs that's closest to you. Find out when they meet. HAS is on the first Friday, JSCS is on the second, FBAC is on the third, NHAC is on the fourth. Don't forget about the Orion telescope, Orion catalog. Just go there and look. Star parties, find out when star parties resume after this pandemic is over. Check the club's calendar, find out when they meet, look at the object and look at the scope. Come to both observatories. Real quick, the 4 clubs, I have the 4 websites listed here in addition to Asset Club that's out in the East Texas area out near Beaumont. All these clubs are very good clubs. George Observatory, if you're familiar in the Houston area, down off of 59 or 288, it's at Brazos Bend State Park. East Dome, Research Dome, West Dome, deck scopes. There's an event we try to run in October. We don't know if we're going to run it in 2020. It's called Astronomy Day. We usually run it toward the end of October. Very popular event. Also up here is the Insperity Observatory off of Rankin Road and Old Humble Road, just short of Will Clayton Parkway. Do some fine work up there. All right, let's talk about scopes a little bit. I see a number of these on Amazon. And I also see some of these, and they can be very, very tempting. I got good news and bad news about these scopes. The good news is the OTAs, or the optical tube assembly, is probably pretty good. Probably got pretty good optics. Orion does not make bad stuff. It's probably a decent refractor and a good reflector. Bad news is I'm concerned about the mounts. The mounts may not be the most steady. In order to move it, you're going to twist these knobs in an azimuth and altitude manner. In order to chase an object in the scope, you will have to turn one of the knobs. Grabbing that knob will send vibrations down to the mount, and the whole tube will vibrate a little bit. It depends how stable this mount is. You may end up wanting to remount this onto something more sturdy. That's entirely possible. Let's look at these. Let's see, this one is originally designed somewhat in a Dob concept where this base plate is on a table and this top plate and the scope spin around it. And ideally the scope is intended for tabletop use, and that's fine too. But they've also decided to put this on a mount. That's a big red flag to me, because to me, anything above this arrow, your center of gravity is higher. I can see a modest-sized child or a modest-sized dog taking the scope to ground. I don't see a lot of heavy weight underneath to holding this thing down. So I'd be concerned about this. This one is much more stable. It's a much heavier mount. Pop quiz. Anybody tell me what the scope is? The Schmidt-Cassegrain. Primary mirror is back here, secondary mirror is up here, eyepiece is out there. On the flip side back here is probably the controller. This is probably, in all likelihood, a GoTo. And that's fine. I believe this is in the upper hundreds, so it's not over 1,000, but this is a decent scope. And it's relatively portable. This part detaches from the base, so it's not a bad scope. Let's come over here. These are Dobbs, bigger Dobbs. This particular one is an Aptura 12. Now I'll warn you right off the top. This is a 12-inch mirror, so this tube is probably bucking 14 inches across. From here, from the bottom plate, all the way to the top, you're probably looking at about 6 feet. Your eyepiece is going to be up here, so that 11-year-old of yours is probably going to need a ladder to look through the scope. It's not going to be trivial to move this thing around. This entire tube will occupy 1/2 of the back of my Prius, and I cannot really get this mount in there without taking the mount apart. So the views are spectacular. I mean, with 12 inches, this is an outstanding scope to have. But you got to have the means to transport it if you ever want to go to dark skies. So one option is over here, the Orion. Now this is the Orion and telescope. This is a PushTo. So this can come off the base, and these tubes can come off. So this becomes separate, and this can become separate, and it's a bit more portable than this one. But part of your assembly procedure is you'll have to align the primary with the secondary every time you put it together. But it's a bit more portable. So there are things to consider here. You got to consider transport. What sort of astronomy do you want to do? Size. There's a lot to consider when thinking about a scope. But as I said earlier, sight unseen, I'll recommend a 6 to 8 inch Dob, preferably the 8, to anybody that asks for a basic scope. Stay away from the box stores, please. Box stores. These Dobs go for a few hundred. As I said, they're completely manual. And the dark side, if you decide the hobby isn't for you after a few years, these kind of scopes will actually have a decent resale value. So, all right. Final thoughts. Do your homework. Locate a club near you. Let's talk about, I talked about Houston area. I'm sure there may be people that may view this that aren't from the Houston area. So you want to Google your town and astronomy club for starters. Also, don't hesitate to go for the Night Sky Network. What is that? The Night Sky Network is set up by the JPL at Caltech. Clubs trip over each other because they want to get involved with the Night Sky Network. Most of the clubs in the country are, because the Night Sky Network offers the clubs educational perks. So it is definitely a mutualistic relationship. They like astronomy clubs and astronomy clubs like them. So what you do is wherever you are, put in your state, zip, city, where you are, and the Night Sky Network can come up with possible clubs in your location. Strongly suggest you do that. So find a club in your area, go to their website, hopefully it's updated, and you can connect with somebody in the club and go from there. When this pandemic mess is over, check their calendar when they start resuming outreach events. Why would outreach events be a problem during the pandemic? Because it involves my queuing up my scope, looking in the eyepiece, and then letting you look through the eyepiece. The eyepiece is a common point. Eyepiece can be a point of infection, unfortunately. So that's why most outreach has been suspended for the time being. A lot of clubs are trying to go virtual with that. But still, you can talk to the clubs even if they don't have an outreach event, and you can connect with somebody in those clubs who can try to give you some additional advice. But if the opportunity ever opens up, go to a star party, look at the object, most importantly look at the scope, and then factor in what do you want to do with the scope. Hint, that's why it's a personal choice. And with that, I appreciate your time. Any questions, you're welcome to hit me by email through one of the clubs, Johnson Space Center Astronomical Society, or questions below. Thank you very much.